Okay, sorry about the crash again. So after reading through the sources here, I cannot find any information about whether this times.txt file, this one, whether this is in milliseconds or maybe another format, but I mean it's pretty obvious that it's in milliseconds because of the long numbers. The big number here. So I will continue with the assumption that this is in milliseconds. I'm also quite sure, but I could not verify this at all, neither by looking in this original or this official source, nor by looking into this code. I don't know, maybe I missed a comment somewhere that tells us that this is in milliseconds, but yeah, I couldn't find it yet. Okay, so what we want to do here in this import LDSO operator is that we now want to load the files. For one, the results.txt file, and there is also the results.noloop.txt file. Let's call that camera optimized and the snow loop, or camera loop and camera no loop. Okay, those two files are to be expected in this output directory, which can be set here. So we will have two files, file path loop and file path no loop, which will both be combined using the variables we just set, like this. And then we will have camera objects. So when we import this text file, or both text files, we will have two camera objects in our scene. We'll have a camera LDSO underscore loop, and we will have a camera LDSO no loop. So we have a camera object loop, and we'll have a camera object no loop. For this, we need to distinguish the cameras, DSO camera loop and no loop. And these need to be put here. Okay, now we want to check if we have a loop object already. So if camera object loop is none, we do not have one. So we will create one. And after creation, we want to assign the camera object underscore loop to sceneObjects.active. So we take the active camera. So if we are creating a new camera, this will be automatically the active object, and we can get this from sceneObjects.active. And we need to do the same for the no loop camera. Okay, and this way we will have our objects stored in this camera object loop and camera object no loop. Now we need to assign the the names to the objects. So we need to say camera object no loop and camera object loop is equal to DSO camera, well, not DSO, but rather LDSO. LDSO camera loop and LDSO camera no loop. And I need to change this here as well. Okay, this is fine. So up until here, we should have 2 new objects created. Let me quickly merge that. So 2 new camera objects should be created. One should be called camera LDSO loop and the other one should be camera LDSO no loop. So before we continue with the actual parsing of the text file, we'll return here, save that file and execute it. No errors. Now we can define the output directory to be the documents. Now I will quickly delete the files here that I have previously exported. And I will now take the results.txt and results.txt.noloop, paste them here. And now they are in this documents folder, even though I'm not reading that at the moment, but I want to prepare that. So with this script executed, I can now click on import LDSO and I have an error. The collection object has no attribute active. Okay. This is because the API changed here. And I quickly need to look that up. So we have context dot scene dot objects. Now we have, I think, selected somewhere, selected objects. Okay, so this will be in the context. Using the selected objects. Whoops. So here I want to get the object at index 0. In both cases. And now this should be okay. I'm saving the file, I'm executing this, and I'm pressing import again if the folder is passed. Okay. Now, line 222, no, 220, I mean, here. I have a typo here. Camera object no loop should be LDSO camera no loop. This should be the string. Now let's import again. Maybe let's delete everything. Okay. Now we have created 2 cameras in the center of the world. One is called camera LDSO loop, which is here. And one is called camera LDSO no loop. Now what we need to do next is we need to now assign the camera transformation to those camera objects. And we can either do that while reading the text files. This is how it is currently done. So here we are opening the file path as the individual poses file. Then we are reading lines. And while we are reading the lines, we are creating the timestamps, calculating the frame ID you want to set, the location, the orientation, setting the scene frame. So we are going to the specific frame where we imported the camera pose. And then we are setting that to the camera object with the location and rotation quaternion. Then we are inserting keyframes. And then we are continuing. In the end, we also need to set the rotation mode to quaternion. Otherwise, the rotation is based on the matrix and not on the quaternion. So this needs to be selected to be correctly. This is basically the same as you would open the sidebar here and change this rotation mode here from Euler angles to, for example, quaternion here. Okay, so let's go through it step by step. We are opening not the file path, but we are opening the file path for loop. As poses loop, for example. Next, we are reading a line. And we are checking, do we have something in this line, or is it none, or end of file? And if we have something, we can strip the line to strip off any trailing and and any spaces which are at the beginning or at the end. And then we split the line, not with the comma in this case, but we are using space separated files. So we need to split using the space later. And then we can extract the individual data. So let's see how we can do that with the poses loop. So we are reading in the poses loop using this file path loop. So we need to update this to be from the poses underscore loop. Then we read the line, store the contents in the line, and we check, do we have this line? If we have it, we strip that and we split it. And then we have the line with multiple values. In our case, we are expecting the line to have 1, 2, 3, 4, 5, 6, 7, 8 parts. That's why we check if the length of line is greater or equal to 8. And we can print the line. Otherwise, we need to continue with the next line. Okay, so in case that we are not continuing, but we are continuing, I mean, we are not skipping this iteration, but we are staying in this iteration. Before I continue, I just noticed that I might need to add what we are expecting. Maybe let's write the indices here. 0 should be let's put another example here. Then we have the translation in meters. Maybe like this. We have the translation vectors. Like this. Then we have the I would say along X. X, Y, Z, and W. Okay, so this is what we expect to get. And now let's parse the line into the individual parts. So the timestamp remains with this line at index 0. However, I will change this int to a float because we are not working with frame IDs, but we are working with timestamps that are given as floating point numbers. Then we want to convert a timestamp to a frame. And this is interesting because in order to do that, we would need to know what the frame rate of the camera was. Or we can simply assume one as given. But I will keep it like that, because the frame number is fine the way it is given here. And we're taking the scene settings and extracting the frames per second from the render settings. And then we are rounding that to the nearest integer. Next we are taking the floating point values of line index 1 to 3, which is okay, for the x, y and z values. And then we are taking the orientation using the remaining line parts. But I will need to check how the quaternions are given in Blender. So let's quickly do that. Quaternion. The quaternion takes in a sequence of size 3 or 4. And the sequence should be W, X, Y, and Z. So this one is in the wrong order. So we switch this part with that one. And then this should be okay. After that, we take the frame that we have calculated and are setting this, or set this frame for the scene. This way, this allows us to step through each of the individual frames in our scene, just like this. I'm doing this with the arrow key at the moment. And for every frame that we have imported, we now can set the camera pose. This is done by creating a vector and a quaternion from the location and orientation data that we have gathered here. And then I have this function that transforms the coordinate systems from the DSO in this case to Blender. But I think this will not be necessary, so in the beginning I will just leave that, but I think we can get rid of that. Next we get a location and a quaternion from this function. And we set the location for the camera object. But the camera object now, in this case, is the loop camera object, which is this one. So camera object underscore loop. Then we also need to set or insert keyframes for the location and rotation. Then we can continue with the poses. Poses loop to read the next line. I think this is not necessary. Let's see. And then we need to set the rotation mode of the camera object underscore loop to quaternion. When we are finished with processing all the lines. Okay, it is necessary to have this line here because we are inside the second while loop. Or this, actually not the second, but inside this while loop. And the other read line is outside of this while loop. Okay, so let's change this DSO importer to LDSO importer. And maybe we can try that out. So I have saved the code. Now let's execute. Now let's check the path. It's still set to documents. Now let's import. And we have could not convert string to float in line 246. 246 for the location. Okay, so there's something wrong with this. Let's look into this terminal window and let's see what kind of values have been read here. So we are reading in this line, which is interesting because it should not contain these two spaces. And I suppose this is because we have a varying number of white spaces. Let's see if we can just split that using the tab character. But I'm afraid this will probably not work. List object does not have a strip. Why did this change the data type of line? List object does not have the attribute strip. So this somehow becomes a list. Okay, let's maybe try to find another method for parsing. Okay, let's try to use the split operator without arguments. So in case I have this kind of test text, if I now run test text split on that, I will get exactly what I want, it seems. So let's do that. Let's run the code and let's import again. Frame set. Frame expected an int type, not float. Okay, that's also easily solvable. So this frame should be an integer, but it is a float. Let's see what comes out here. Now setting frame. Okay, that's a very big frame. Okay, I need to strip off the beginning. And I need to convert it to an integer. So this round is not enough. We need an integer around that. Now it should work, but the problem is that the numbers are very high because we are starting with a very high value, which we are then converting to, like, we have this absolute value here, but we need the relative one. So we need to subtract this first value from every timestamp. And we do that here, I think. So we take the first element in the line. We convert that to a float. And we check the length again. If this is greater or equal to 8. Otherwise we put it to 0. I mean, I could also move that outside. Okay, so this will be a float. Now we need to offset that. Okay, I think this should do the trick. Okay, at least it is working. And there is some kind of animation. Let's check in the animation layout. Okay, it's not an animation. This did not work, it seems. It's setting the same frame always, which is weird. Okay. So something is wrong with the calculation of the frame. So the timestamp is in as a float. It's given as a float. I think I will get rid of this round operation. And I will set the render FPS to a value. To 1000. Which makes this calculation unnecessary. So let's see if this at least will solve the problem with the wrong FPS, the wrong frames per second. There are still very high values. Okay, so in this case, I would do it differently. I would say we start at count is equal to 1. And just use the count here. Let's delete the cameras. And let's execute the script and load in a file. Okay, now something is happening at least. Okay. This is weird. Let me quickly just set the end frame of the scene of the animation with scene.frame end is equal to count. Count is available here. So once again, I'm deleting everything. Let's save this file and let's execute it again. And nothing is happening. Why? So the frames are set. Okay, I somehow did not click. Okay, it looks like this is already looking very, very good, I would say. Let's display the motion path. Let's maybe change the display. Okay, so obviously the timing is off. But other than that, it seems to work. Maybe switch into camera perspective. Okay, now what is off still is the camera calibration, of course. But let's see if we import the point cloud, if this is somehow matching or if there's a problem. Let's do file import and then ply. I did not copy that. So I copy the point cloud from the backup folder into this folder. Let's refresh. Okay, so the coordinate system is off as expected. But maybe that's a simple rotation. It's not looking too bad. It's actually looking quite correct. Let's make it bigger. This looks quite good, to be honest. Unfortunately, the colors are missing, obviously. Okay. Yeah, what is missing is the no-loop camera still. I definitely want to avoid any code duplication. So if I would just copy this code and put it below the existing code with the change of the names, the variable names, then this would be quick, but also dirty. That's why I would ideally put that into a function, helper function. And there are some helper functions above. Now, the thing is, I'm not very happy with just putting that to a function or extracting that code and building a function around it. But I also lack a better idea at the moment. So a function would be a good start, but I'm definitely not happy with this solution. So let's just make this a function for now. Maybe call it import LDSO. Or parse LDSO with a file name and an object. I think this should suffice. So if we have file paths and we have objects which are named. Okay, somehow this should be placed here. This is a poses loop. Let's rename that to poses, as it was before. Need to pass the scene as well. Okay, so now we have this generic one here, this generic version, the first timestamp. We will have to pass the scene. He will have to put in the OBJ. And here as well. And we can take this out. Okay, we cannot take this outside. For now, at least. So let's keep it here. And let's just try to call this method with both objects. Parse LDSO with file path loop and file path no loop. Then the object is loop and no loop, and the scene is the same. Let's save that. Let's delete the camera objects. And let's run the script. And let's now click on this import LDSO again. And we do not have results.noloop.txt. Okay. Really? Okay, it's results.text.noloop. Like this. And let's also change the UI. To this one. Save it, execute, and delete the camera poses. And now we import again. And we'll check. If we go to the loop camera and we go to the animation, if we play that, and something is wrong. Oh no, everything is fine, but this one in the animation layout is, I think, not rendering the points. Yes, like this. Okay, so this is the one we saw before. So this looks all right. Obviously the field of view is off. Let's quickly maybe change this for this instance of the camera to something wider. Maybe it was more like that. I think this is closer to the data set. But of course, it would be best to use the actual values of the focal length. Now, what about the second camera? Let's maybe copy the focal length from that. And let's switch to this camera view. This should be, I think this should be the same because we do not have loop closure enabled in this case, I noticed. Okay, there is a small difference between those two cameras. So they are not exactly the same. Let's create the motion paths for both of these cameras. So this is the loop camera. We color that one using red. And the no loop camera should get the color green. And now we can check the paths. They look very identical, but there are specific differences here. But they look very close. I'm still not sure why there is a difference, because if we have loop closure deactivated, it shouldn't do anything, right? Maybe these are just numerical instabilities. But the end is definitely closer to each other than the beginning. So comparing that, it's definitely something to look into. But, ladies and gentlemen, I would say for today, this should be it. So we have several things, or I have several things that I still need to I need to polish them. The first one being, of course, we have this oh, it's the debugger, or yes, it's probably the debugger. So let's continue so that we can look at the reconstruction. So what we have done in these three parts, I think it have been. So we had those three parts due to stream crashes, unfortunately. But what we have done in those three parts is, first, we have added this coordinate system, which is very, very tiny. The line width is very small, so I could increase that. The next thing is, unfortunately, even though the user interface shows the world coordinate system and the world grid as new options, they are not showing up. I'm not sure why this is, because this should work. If this coordinate system here for the cameras works, and this should also work. So I need to compare that with my implementation for DSO, because, just as a side note, for the For this repository, this visual GPS slam, I have also altered the DSO to show that. So, for example, yeah, local coordinate systems, like here. Okay, this is the predicted. That's not what I'm referring to. Yeah, I added this draw cam. I added another argument for bool draw axis. This is something I should probably also do. Oh, and then there's a pangolin GL draw axis. That's interesting. Okay, didn't know that anymore. I forgot that pangolin offers this draw axis command, it seems. And then camera and also here GL draw axis. So I think I can try that in the next stream to just use this function. This would make things a lot easier. But then there's also this GL lines, and where is this? This is probably in the run method. So this is what I did actually. I have this if this settings maybe. Maybe this is wrong, that I have not used the this dereference operator or the this pointer. Let's see. So here I'm just checking for the if setting is enabled. But this is the same case here, so this should work. Should not make a difference. But here they are also using this pointer. And then they are not using this pointer again. So I need to investigate that off camera a little bit to find out what exactly the issue is here. Okay. But then we also looked into a little bit of the debugging. So we have checked what is happening behind the scenes. Not to a big extent, but a little bit. And then in the end, we have now imported the PLY file into Blender. This is something that is shipped with Blender. But we have changed the add-on from 6 years ago that I have created to also import not only the DSO trajectory, but also the LDSO trajectory. So with this add-on here, we now have this new button that allows us to import the LDSO, results.txt and results.noloop.txt, which is I think wrong, right? Let's double check. Results.txt.noloop. So text.noloop. Okay, so I need to, I think, re-execute this script because I changed this. So results.noloop.txt. If I execute this, it's still like this. Text.noloop. Why is that? Results text no loop. That's text no loop. Maybe I did not save that. That's not text.noloop. Should be correct. Unless, of course, this depends on the operator. And the operator is given here. can get rid of this print command. Probably it's this one that is used as the label for the button. Okay, let's save that. And let's execute. It's still the wrong one. Results.txt.noloop. Okay, maybe I need to refresh the whole Blender user interface. But given this command, that's not, I'm really not sure why this is not working. Okay, whatever. Given this new functionality, this new button, we can now import the camera trajectories that have been exported from the LDSO Twitch version and import it. There is also an issue here, that is the timing is off. So at specific points it's very fast and then it's very slow, which is not according to the video, so work needs to be done here as well. And in the best case, we would also import the camera calibration from a text file and set the virtual Blender camera to this camera calibration text file. But in general, the idea is clear, I think. We can work with that already, I would say, and these improvements can be done in a later live stream part. So if you have joined me up until now, I want to thank you very much for watching and for your support if you are following. And yeah, stay tuned what we will do in the next parts. Until then, have a great time and see you next time. Goodbye.
For you, even when there's nothing.